Um, I'm Klaus Jorgensen. I'm a program manager in the Windows File Server and Clustering team. Last year I was here as well talking about SMB transparent failovers, if you might remember. So this time we're going to talk about file-based storage in Windows Server 2012 R2. So if you haven't already caught on to the fact that we are moving SMB in the direction of supporting server-based applications focusing on workloads like our own Hyper-V and SQL Server that can use SMB as a transport to get to its files on a remote file server solution, then this would hammer it home, because if you look at the positioning we're doing, I'm just letting you know this so you know what context we're moving into. Positioning we were doing in the recent events with the disclosure of Windows Server 2012 R2 to the world is this infrastructure as a service storage vision. So basically, the Microsoft communication to the world is when we do Hyper-V deployments and infrastructure as a service, it is over SMB to a backend file services storage solution. And in our case, it's file server with our own storage spaces configuration behind it. So that's the message that we're telling the world that how they should do infrastructure as a service. The benefits that we see in this is that in contrast to when it's all co-located, is that you can administrate the virtualization layer separately from the storage layer, as well as scale the two layers completely independent. And because we're making, as you've probably seen, all the investments in the performance and et cetera in SMB and the reliability in SMB, then the difference in performance between local and remote is very negligible. So the SMB enhancements from a positioning point of view are really in a few buckets like performance, optimizations, diagnosability, and manageability. So I'm going to walk through each one of these with you right here. So the first one is that even though we've changed the protocol version to 3.0.2, in our official documents, etc., we will still refer to the SMB 3.0 protocol, treated as a family, right? But there is a dialect change with the release of Windows Server 2012 R2 and the corresponding Windows 8.1 client operating system. We have minor non-breaking protocol changes since Windows Server 2012. In a few instances with multiple SMB instances, optimized rebalancing, and remote RDMA validation. I'm not going to cover these in detail. David's talk right after me will cover all the protocol changes in great detail. So hang on for that. So starting out with the looking back. So what we have done here is basically in Windows, we made it so that support for SMB1 and all earlier dialects is now encapsulated in what we call a feature in Windows, which you can completely uninstall. What that means is if I uninstall this capability, I completely remove the binaries on the box that supports those dialects. So from your point of view, if you are interoperating with Windows, which I assume you are in some cases, then you would think about that there will potentially be deployments out there where this is completely turned off. So this box will now only talk SMB2 or higher. Right? Why are we doing this? We're doing this so you can remove the older dialects and older components to reduce the attack surface of the operating system, as well as the servicing area, meaning that if changes are coming out, these binaries are not installed, they will not affect that box at all on, for lack of a better term, on Patch Tuesday, for example. When you remove it, as I said, you remove SMB1 and all earlier dialect support, as well as the browser and wrap components are also getting removed. Any questions? No. Feel free to ask questions as we go. You don't have to hold them to the end. Yes? What about NetBIOS? Is it dead now? What do we think?
It still ships for the operating system. That's a different team that makes that decision.
Yes. Anyone else? Is that the same question? Yes. How does it affect what? How does it affect Windows XP deployments? Well, if you uninstall this on the server side and you have XP in the environment, then they will no longer be able to communicate with this server because XP supports SMB and earlier dialects only. So if you have XP around, you will probably not want to remove this feature. It's, it is enabled by default, so it's still there. It's just completely packaged into a feature that you can completely uninstall. So it's on by default, if you will. Any other questions? All right. Enough of that. So the other part is that because of this, that the path we're going into these server applications on top of SMB, the SMB direct capability is very important to us because that's where we get the real low latency and high throughput, as well as that not coming with a steep penalty on CPU, right? So in this release, in our implementation, we have done a 50% improvement in the IOPS rate at low I/O size. So we're looking at it specifically an 8K IOPS because that matches very well to what our SQL Server implementation and most OLTP database implementations do, which is a very important workload. So we've moved it from 300,000 IOPS on a single interface to 450,000 IOPS on that interface. So same hardware, but better throughput. This, of course, helps us in a way that when you look at a Hyper-V host that might be running multiple like SQL or Oracle databases inside a guest, the fact that we can do more throughput means that you can pack a higher density on that Hyper-V box because the CPU is freed up to do real work, I would say, rather than just moving data. Any questions here? All right. Another thing is what we call multiple SMB instances. So what does that mean? Traditionally, there has been one SMB server and one SMB client in every copy of Windows, if you will. So in a scale-out file server configuration, which is our backing implementation for server app workloads, each node will now have 2 SMB server instances and SMB reader instances. The one instance will handle all the regular traffic, all the traffic that you've seen in the past. And then there is another instance that will be specific to the traffic that goes between the nodes to support what we call the cluster shared volume file system. Right? So the cluster shared volume file system, if you don't know, is basically a file system that allows us to expose data from a volume to all the nodes in the cluster. And it uses SMB as an intranode transport for moving data. And what we're doing here then is basically there's a separate instance of SMB client and server that handles that traffic to separate it completely from the traffic that is coming in and out of the cluster. And if you want to go and learn more about CSV, there's a link to that here. Any questions on this? David will be covering the specific protocol changes for this particular feature. All right? Another thing that is related to our scale-out file server is that with certain storage configurations that only allow us to do I/O to storage on one node, one specific node, as opposed to any node can do the storage. We had in the past the situation where traffic will be coming in from a client on any of the scale-out nodes, and then on the back end, that traffic would be forwarded over that SMB channel that I was just talking about before to the node that can actually do the I/O to storage. So the change here is that if we understand that there's storage behind on the Windows file server that can only do I/O on a single node, what we will do is we will actually tell the clients that are connecting to that, there's a share that sits on that storage, to actually go to the node that has the direct connectivity. So we're basically moving the client to the best node possible in the cluster. This will allow us to avoid this double hop effect where you would come into the cluster and then be redirected The response will come back to that node and go back to the client, right? In our implementation, then CSV, the cluster shared volume file system that I was talking about before, has an owner in a cluster. So there's one node that controls basically all the metadata to that volume. So there's one node that's the owner for that. And in this implementation, we will simply redirect the client to the node that is the CSV owner. And the CSV owners will be load distributed across the cluster by the clustering infrastructure. And this will happen when you add a node, remove a node, if you pause a node for patching, etc. And what that really means that the SMB connections are now managed per share, no longer per file server instance on the cluster. Any questions on this one? So the question is, this is where we use the new witness capability. That is correct. The client comes into the cluster. It does just like in Windows Server 2012. And then we figure out, hey, this is storage that does not provide parallel data access to the actual storage. So the witness channel will come back and tell the client there is a more optimal server you can go to. And then the client will seek that node. All right? Improved SMB diagnosability. So this is, for us, a huge step forward. We basically, with this diagnosability, and you will, if you provide backends, and you see from the a Windows client, or you provide frontends that goes to an SMB file server, you will see that it has become a lot easier to troubleshoot scenarios where things do not behave as you would expect. So a lot more scenario-based events where we will have intra-machine information. So we will log more information about what is the client that actually experienced this error, what is the IP address, etc., on that client. All the useful events are enabled. So basically the intent here is to, instead of having this situation where something didn't quite work the way we expected it to, now we have to go enable all the tracing, etc., and then we have to get that set up again, and then we can go look at the traces. The intent here is to say, just based on the events, we should be able to troubleshoot what went wrong. So once you hit it the first time, you already have the data to go look at it. Right? That will help you in your interoperability, and help our customers in quickly figuring out what's going on in the system. The other part is that we have really took a look at all the events that we're firing into the event log in Windows. And some of them were more noisy than others. So we have been doing a lot of work to filter down and just log the events that are really necessary so that logs actually keep a longer time and you will be less noise in the event log. And then there is inbox SMB tracing that can be enabled using the netsh command. Any questions to this capability or change? All right. You're easy on me. That's good. So here's another use, and I just highlight this because there's another use of SMB. So if you're familiar with Hyper-V or familiar with any virtualization technology for that matter, there is a scenario where you live migrate a virtual machine from one computer to another. In that scenario, you have to move a lot of data really quickly because as these VMs grow larger, for example, if you run a SQL server that has 128 gigs of memory, you're transporting a lot of data because you're transporting the memory image from one server to another. This is the perfect use case for actually adopting the SMB protocol, especially with the SMB Direct/RDMA capabilities where we can move a lot of data really quickly with very low CPU cost. So in this release in Windows Server 2012 R2, the Hyper-V team has implemented the capability of using SMB with RDMA as a transport for Hyper-V live migration. And that, of course, gives us all the usual benefits that we get from RDMA. And what we have basically seen is a very fast move of VMs between two machines. Questions? Nope. Now, with these new uses of SMB, Now comes the time to say, hey, how do I control such an environment? Say I have live migration traffic going between virtualization machines. I got traffic going between that same box and the backing storage, and I potentially have some traffic coming into the server. So what we're introducing is the ability to control the different types of SMB traffic that can go and happen in a Windows box. So there are 3 predefined categories. There's default, which is everything else but the other 2. Then there's virtual machine and live migration. And then we've implemented PowerShell command, so you can essentially say, what's the bandwidth limit of consumption that this particular SMB use can do? So if you look at the diagram over here, you can see how this guy is limited to 100 megabytes into the Hyper-V host, live migration between to 500 megabytes, and then from the Hyper-V host to the backing SMB server, no limit. This is just an example, but that's essentially what you can configure there. So this is limited today to what is the upper bound that can be consumed in terms of bandwidth, right? There's no IOPS control, et cetera. It's pure bandwidth.
So if we get into this later, that's fine, but is that actually just implemented as policy on top of SMB, or is that implemented as quality service?
So the question is this a policy on top or inside the protocol itself?
I mean, is this like assigning NICs for a specific use policy? Or is it actually
It's actually implemented at the IO layer of the form of there's no protocol.
Okay, so this is strictly management. Windows management.
Yeah, where you can basically, and I don't actually talk about specifically operating.
Yeah, that's fine.
All that,
Yeah.
So is it?
Is this working? Okay. It's implemented in the the NTIO layer above the redirector, so there's no protocol changes associated with it, and it's more about just controlling and balancing the overall throughput that goes out. So, yeah, and ask me later if you have other questions. Yeah. For Server 2012 R2, the classes are static. So there's live migration, there's Hyper-V VM traffic, and then there's other, which is basically anything that's not in either of those 2 classes.
All right. Any other question? SMB delegation. So in the scenario where I have a SMB server and I have some Hyper-V hosts that are using that SMB server as backing storage, and I have another machine that I use for management of these Hyper-V servers, you get into what we call the ABC management scenario, where you have one machine that is managing another machine that is really consuming resources on a third machine, which means that when you manage these machines, you have some sort of delegation to happen in order to manage the file server shares. So that can be rather tricky to configure in Active Directory with constrained delegations and resource-based delegation. So what we have done here is we have provided a set of simplified commandlets that allows the user, the Hyper-V administrator, to set that up. The benefit here is that it does not require domain administrator rights. It leverages the resource-based Kerberos constraint delegation, and you simply configure it per SMB client server pair, like shown here in these PowerShell commands. So that is useful in these Hyper-V over SMB scenarios or similar SQL over SMB scenarios. Any questions? All right. Then I'm not going to go into details, but this slide essentially highlights the other changes that's been going in through the PowerShell-specific management of SMB, including some changes around optimized rebalancing, SMB witness, where we simplified some of the names, how you can get info into the multiple SMB instances, because by default we just provide the default instance information, and around the permissions that can be set. So I'll leave it up to you to look at that offline if you want to look at it on the Windows. So, Ned, do you want to talk about DFSR?
Is it working? You hear me okay? Oh,
Yep.
there it goes. Thank you. My name's Ned Pyle. I'm a program manager in the file server cluster team, along with Klaus. And the SMB diagnosability feature is mine, so if you have questions on that you think of later, you can circle back around and ask me. But I also own DFSR, which I don't know how many people in here know even what DFSR is. No one. Okay. Totally proprietary Microsoft technology, so not much interop going on right now, although it's all documented and you could if you wanted to. Big chance. Yes? Distributed File System Replication. Oh, sorry, the acronym was the question. What does it stand for? Distributed File System Replication. It's used by domain controllers for sysvol, and it's used for custom replication. Yes? Yes, I know about at least, it was a statement. You are doing some interop pieces right now. You're from Samba, I believe, right? That's why, yeah. I want to talk to you later about that. Cool, so any other questions about what I'm even talking about? No, okay. So it's going to be a little interesting when you get no context to see a lot of recent work done, but DFSR is a multi-master state-based replication system. It scales to thousands of nodes. You have customers with 3,000 or 4,000 servers replicating geographically. It's all chunk-based replication, a protocol called RDC, Remote Differential Compression. I could spend 5 hours on this, so I'm going to cut myself off. What it boils down to is we've not really taken major investments in this thing since 2008 R2, and 2012 was basically like less than a maintenance release. We just did some bug fixes. That was it. So we circle back around in R2, 2012 R2. There's a lot of R2s now. And we decided to work on two major areas, the scalability performance side and the manageability sort of reliability side. This is used by a lot of our customers. It's almost guaranteed that they'll be using it in some cases because if they've got Active Directory, it's one of your only two options for sysvol, for example, the other one being FRS. So the first thing we did was say, well, we've never increased our scalability numbers on this, and the way to do that, having moved past, when did this start getting written? 2002 was when this was written. And so 10 years have gone by, 11 years have gone by. A lot of things have changed as far as the size of data, the width of networks, all the types of things that you guys care about. And so the first thing we said was, well, let's take away the biggest problem. The biggest problem is when I set up DFSR or any file-based replication system, any one of them that are like that, there's always an initial sync period where the two or the end servers decide that they're in sync, they know about all each other's data, and they can continue on to replicate changes as they happen. And that first phase takes forever. It's really, really super slow. So to short-circuit this whole process, what we decided to do was create a way to precede the database itself by creating one server, letting it, through local I/O quickly enumerate all of the data that it's going to replicate, fill up its database. We can ship the database to other servers, having scrubbed out some information about them, and then they can slurp it up and start using all of that information along with some validation that we do on the way out and in. Yes?
When you say ship, do you mean physically? When you say ship, do you mean physically?
Yes, so the question is, are we physically shipping it? So you can take this database and export it with PowerShell. You can robocopy it, you could Xcopy it, you could put it on a disk, you could mail it through FedEx, UPS, put it on the server, and if you had like an especially bad connection between those servers, you actually ship the data as well. You could take a really big hard drive, or maybe it'll fit on a Blu-ray, whatever the storage is, put that on the end server or servers, and basically set up replication with this exported database. When we export, we save some information about the files on the way out, what we call our validation information. And we have several levels of doing so, which I can talk about if you care. But what it boils down to is this server knows about what his files were so that he can validate that the files that are on him appear to be the same. And if the database is the same and the files are the same, there's no need for initial sync. And this takes, like in this particular example, and it's actually faster than this because this is a 7-year-old server we did this on, a pair of servers. But 100,000 files in 500 gig would ordinarily take 13 hours to synchronize. Just the initial sync of deciding that they're in sync, not actually copying a single file. We take that down to about 2 minutes now. If we take, we just did a 10 terabyte test, which usually would take us about 3 weeks. 5 weeks. We take that down to about 4 hours. So we're pleased about this. It's new, and we're sure there's bugs there, but we're hoping that customers will kind of get like a fresh lease on life with the FSR and want to use it again for bigger workloads. Because we've added this, we also kind of accidentally gave ourselves some capabilities to do things like replace hardware and upgrade the OS and stuff, where you'd replace those things, and then you'd have to go through initial sync again. A server that was working perfectly fine for 3 years, then you had to replace it and start over again. We take away that start over part with this feature. We did some tuning options. Kind of embarrassingly, they're things that we've had for years that we're turning off. Because when DFSR was written, it was designed to work immensely well on frame relay. And like a T1 would be like, whoo, you guys got some cash. So we were optimized for these really sort of like high latency, low bandwidth, not very reliable networks. And networks have gotten a lot better, and we hadn't really started taking advantage of those. So you now have the option to sort of turn off some of our things that were optimized for really bad networks and used more of your network. Especially on a LAN, we can get about twice as fast now by turning off some things that were mostly local I/O processing on both nodes in a partnership. That we'll just say, well, just don't do that anymore. Just copy the files. And all this stuff, along with the next slide, we've taken basically an order of magnitude improvement on what we'll replicate. So it used to be about 10 terabytes and 11 million files. And now we'll support 100 terabytes, this is per node, and 100 million files. And that's only what we could test. We got some great hardware from a nice OEM of ours, and we only had 220 terabytes of storage. And that's what we could test. And with this particular component, we don't like to make support statements about things we can't test, so we stick with what we've actually validated. Are there any questions on this slide? No? Okay, good. I'll try to go faster. The other half is we added all these PowerShell for all of it. WMI v2 provider, which is basically a port over of our old v1 provider. So we get the protocol enhancements, but of WMI v2, which is WS-MAN protocol, HTTP-based WMI. And then we decided, well, we're doing all this work. Let's maybe make some decisions based on the last 10 years of how we didn't do things so great the first time around. So we added a lot more capabilities to the management by saying, well, from now on, you'll be able to set things up, and it'll actually be the best practice. And a lot of the tools haven't changed really in a decade, or nearly a decade. We learned a lot of things since then about how we want customers to set things up if they just keep wailing on the next button. And the PowerShell will do that sort of, if you're wailing on the PowerShell next button, it's doing the right setting for you. And then you can opt out, or you can opt into a terrible setting if you want, but we'll try and do the best thing we can for you. We try to support things like collections and globs or wildcards. We try to make it so that you could make massive changes. We call it the giving you enough rope capability. So you could, massively alter everything at once, or alter just, 20 servers, or find 1,000 servers and alter them, that kind of stuff. We wanted you to give those options, because right now, unbelievably, we have this multi-master system that works on 5,000 computers at once, where you could only, in our management tools, edit one at a time, until now. And then these are more, things we've learned over the years about, our own reliability pieces. We learned with a lot of pain that when we're having database problems, DFSR has a JET database, an extensible storage engine database for each volume that has some replicated content on it. And databases get corrupt, get damaged, they have semantic problems, they fall apart. And for many years, we operated under the assumption that, that nothing could be wrong here, nothing could be bad. And then we started actually investigating it and finding that we could lose data in some cases. We actually went through and did a complete sort of end-to-end code review as part of this process to we found some preemptive fixes. Things that have been ticking time bombs for years probably have affected some customers. And then also we decided, well, if we're going to do this, we're going to do it right. And if we have database corruption, we're no longer going to say throw away our database and just start over. Because DFSR is multi-master. It has a conflict algorithm based on age. And that means that somebody has to lose in the event of a tie. And we use last writer as the win, except during database recovery. Database recovery is you always lose. And we decided to finally fix that. So database recovery now goes back to being just like all the other reconciliation algorithms we use. Which doesn't sound like much. It sounds like something that should have been there since day one, but it's sort of earth-shattering if you've been using DFSR all this time. And the ability to handle dirty shutdowns and some other stuff that you probably don't care about. Are there any questions on this? Nothing. Excellent. All you, buddy.
Thanks, Ned. So shifting from DFSR to another protocol that we have in Windows, that we support in Windows, is NFS. Naturally, it's there for serve non-Windows platforms. And you want to say a word, Sridhar, or do you want me to just cover it? All right. So all the support that we had in Windows Server 2012 is, of course, still there in Windows Server 2012 R2. So we support NFS v2, v3, and v4.1. For NFS v3, we actually built in Windows Server 2012 continuous availability into our implementation, so that if you have NFS v3 sitting in a cluster configuration and one node disappears for whatever reason, you could transparently move the NFS export over to another node, and the client that will be using that, would it be a VMware entity or another NFS client, will just transparently move over to the new server and continue to access the store. That is actually not new in R2. That was in Server 2012 as well. And then there is the NFS v4.1 implementation that was also in 2012. Any questions on NFS? Multiple. Start here. Maybe we should wait for the mic then. Yes. So Sridhar is the NFS program manager. So he owns NFS from a program managing perspective. And he will probably be the one that's actually going to answer your questions. Maybe I should hand the mic over to him.
So I guess 3 questions. One is, are you going to talk about NFS client? Do you have any NFS client enablement in the same time frame?
You might want to come to the mic and just have a conversation between the two of you.
So we have NFS v21, v3 inbox client that's being shipped. And for 4.1, we don't have inbox any client support, but you can download it from University of Michigan, the UMich city. They have a 4.1 open source client code there, so you can download it.
And the follow-on questions. One of the things we deal with a lot is cross-protocol when you're exporting both NFS and SMB3. There are a set of optional features that are interesting to talk about. Is there a chart anywhere that has, first of all, the optional features that you've enabled in 4.1? I guess you don't do 4, you just do 4.1? Yeah. And then finally, the things that matter most for cross-protocol appear to be ACL issues and locking conflicts. So we're wondering how you're handling POSIX advisory locking and sort of the rules that you use for that, so we can sort of think about best practices for cross-protocol when you're exporting both SMB3 and NFS.
Yeah, so we are working on kind of best practice to kind of see how those two protocols work together, right? So specifically on the locking, so NFS v3 and v2 all implemented based on NFS, the RFCs, completely implemented based on the protocol infrastructure. And if you're talking about locking, so you can export the same share from both NFS and SMP, right? So when you get a locking, so we are basically leveraging the underlying, say, NTFS file system locking. So like if you're locked through SMB, that will get the lock for the same file. And when you go through the NFS, it will say that, okay, it's already been locked, or the vice versa there. Right, so it master like NFS itself won't do the locking. It leverages the underlying NTFS file system to do the locking on its behalf.
But as mandatory locks.
Yeah. So his question is like about more mandatory locks. He's talking about the locking between SMB and NFS and how it leverages the how it is being done on an interrupt situation, right? So I believe I can get back to that, like on that particular information. I'll check that one and get back to you on that. So on that.
And the final question that comes up all the time, and it came up in RFC meetings, it came up in Connectathon for a number of years, is how you expose the mode in the ACL. So the problem that's common is you change the ACL and you destroy the mode that the V3 guy is returning. So to at least not screw up backup, not screw up, tools, be helpful to know how you're storing the mode for the V3 guys, because they're going to want the mode. They need the mode back on all these calls, the Unix mode, in your ACL. So obviously there's no perfect mapping, but this kind of thing has been done many times, and for compatibility across protocols and clients, it's really important to understand how you store the mode.
So for the V3 or even the 4.1, for the mapping point, we basically follow the POSIX, like read, write, and execute from the user mode, user and group. So very similar to the NFS stuff, right? And there is, I know for SMB there is an extended ACL stuff. Like you can, very detailed ACL support there. So we will be, if we don't have that 4.1, even 4.1, we have the basics POSIX kind of that read, write, execute attributes. But we'll be, in the future, like we'll have the complete support for the entire ACL support between SMB and NFS. We don't have the full-fledged, like, complete, width of or breadth of the ACL support that we have in SMB in NFS.
The simplest case is, how do you store your mode? Where is it documented? Because if you store the mode in a way that can be retrieved by applications, we won't destroy your compatibility, right? So one of the things we need is just to be able to understand what document describes how you store the mode in, like FSCC, FSA, that describes how you store the mode in NTFS.
Yeah. Is there additional question?
I had, there used to be a document. So my question was, I know that there used to be a document that is essentially just a sort of different ordering between allow and deny aces to implement the mode bits. Is it still done that way? Because Steve, I can point you at that doc actually, and maybe that'll help. You can go on from there.
Yeah, nothing changed on that front at this time, right? So we are looking into it to improve it, and also hopefully in one of the future releases we'll have additional ones. But yeah, I believe like you can send that link. Thank you so much. Any other questions on NFS? So you have a lot of implementation there, like with the compatibility point of view in NFS, SMB.
I mean, it's a very common problem, and as you probably know, the features of NFS and SMB have sort of been following one another, and the traditional problems that we see when running on a Linux or on other platforms has always been ACL compatibility and handling these advisory locks, because clearly Windows doesn't have advisory locks unless you've just added something here. And so mapping these into the file system creates semantic differences for NFS when you're exporting it the same thing multiple ways. With 4.1, you now, well, with SMB3, you're now introducing other problems because continuous availability provides guarantees. And so the other problem you historically see is when you have a continuously available share and you're exporting it via NFS, what does that mean for lock recovery? Once again, back to mandatory locks, POSIX, advisory locks, not losing them. These are the traditional questions that come up. But Linux has obviously supported this for many years, as most NAS has supported for many years. But those are the questions that come up most often, and the thing that's most important from my perspective is understanding sort of Windows behavior so we don't screw it up.
Yeah, at least just to kind of point out on the continuous availability for NFS v3 clients, like we are leveraging this the status monitor, which is the NFS server. When it's down and if the other side comes up, usually like the client waits for the RPC timeout to reconnect from to the new server, or whatever server it is trying to connect with the same IP or net name, right? So by doing this continuous availability, what it really means is the server can fail over between the, if one file server is down, the other one takes over. And then they can send the NSF notification to the client saying that, okay, now I am the guy, come and connect to me, instead of like letting the client waiting for waiting for a long time. So it's kind of like there is nothing like a key or something that is being stored in the server per se, but it is more like the client will be able to reconnect. The logs will be there, and it is that same protocol. Like it will wait for the log. I mean, the client is already holding the log. It can reconnect and claim the log. Like there is a grace period and all those things. So all those things. So basically, the NFS implementation is based on all the RFC, the protocol, strictly followed protocol there, and then with interop with the SMB. Basically means that the same share could be shared out from both NFS and SMB, and that locking things are basically we are leveraging the NTFS underlying file system to handle that, and then all this POSIX stuff is completely implemented in NFS. But we are working on improving the more documentation on certain, especially on those interop point of view, and then we are hoping to get it done like in the next few months.
All right. So maybe you guys should have more conversations following up after this.
So the question is about name sensitivity and file name. There is a checkbox option available, like whether you want to have it on or off. The question is about directory level or NFS configuration. I think it is at the configuration level, the overall thing, not necessarily on particular directories.
Thank you. So moving on from NFS to iSCSI, how many in here are doing any work with iSCSI? A few. Oh, more than a few, 5 or 6. So I'd like to introduce Mallikarjan. You want to stand up? So Mallikarjan is the iSCSI software target program management owner in Microsoft. So he can answer any questions you want about iSCSI, right? You want to chat about these slides, or you want me to go through them? All right. I will pretend I know something about iSCSI, and then Mallikarjan will answer your questions, okay? So some of the big changes, and if you are doing interoperability, some of them may or may not apply to you, but one of the things is that the iSCSI software target that is now inside a part of Windows Server is now supporting VHDX as files behind it, which means that we can provide much larger VHDs, up to 64 terabyte. You can online shrink and expand these VHDs. Well, then means the LUN shrinks grows as well. You can progressively dynamically growing LUNs, and you can zero them out as you provision them. The other part is that the iSCSI software target now fully supports being managed through SMIS. The virtual disk, oh, that's a build slide. Is that you got the VHDX file. The other part that is worth calling out here is that that you may or may not know is that in Windows Server 2012, the iSCSI target, as it was put into Windows Server as a default part, also introduced the continuous availability capability. So if you sense a theme here, then yes, in Windows Server 2012, it was about continuous availability because we added that to SMB, we added that to our NFS implementation, we added that to our iSCSI implementation on the server side. So in Windows Server 2012, we used the VHD 1.0. I think we covered that, right? Yes.
Yeah.
Then there's some GUI, which may or may not introduce how to do this. And then the SCVMM. So because of SMIS support, you can now fully administrate the iSCSI software implementation through the Microsoft System Center Virtual Machine Manager. So all these scenarios, discover, all the various create, add, list, mask, and unmask are fully supported. Sorry, I whipped through that real quick to make sure we stay on time. Any questions to the iSCSI software target, whether it's related to this particular release or the iSCSI software target in general? Or any interop with the iSCSI software target? All right, well, Mallikarjan is here. If you want to do some one-on-one with him, you can do that as well as with Sridhar if you have further NFS questions, or with me or David if you got further SMB questions. So, and Ned, if you got DFSI questions. Sorry, Ned. You're so easy to overlook.
Well, that's all.
All right, thank you very much. Next up is David's talks. Is that 10:45? Yes. And he will talk everything about SMB that I didn't talk about. Thank you.